Hello, class. This is Mr. Eggleston, and this is your spring final review for Algebra 1, Part 2. I already did 1 through 11 in the previous video. Now we're picking up at 12. On 12, they tell you the first few terms of a sequence are given below, and they want to know, is this sequence arithmetic, which means we're adding the same number, quadratic, which means we're going to have to look at what that means, geometric, which means we're multiplying by the same number, or none of these. Well, it's easy to tell about the geometric. You can tell if to go from 12 to 9, we would have to multiply by 3/4. And then to go from 9 to 5, it's not 3/4. So you're not multiplying by the same number. So it's definitely not geometric. So let's look at to see if it's arithmetic, which means we're adding the same number. Okay. To do this, we just go, okay, 9 minus 12 is -3. 5 minus 9 is -4. 0 minus 5 is -5. -6 minus 0 is -6. And last, -6 minus, or -13 minus a -6 is -13 plus 6, which is -7. So this is the first difference. If this had been constant, then you would say it's arithmetic, because you're adding the same number each time, but it's not constant. So we check the second difference. And we see -4 minus a -3 is -1. -4 or -5 minus -4 is -1. Each one of these differences turns out to be -1. This is the second difference. So you would say, since the second difference is constant, that is, it's -1, this sequence is quadratic, because the second difference is constant. If the first difference was constant, if this number up here was constant, then that would be linear. And we already saw that would be arithmetic. But now it's the second difference that's constant, so we know that the sequence is quadratic in nature. And then you could devise a way of finding out what the quadratic expression would be, but that's not for this class. It would be in Algebra 2. All right, but you know that if you wanted to model those numbers, it would have to be a quadratic function because of the second difference being constant. All right, number 13 is a thinking question. They said, which of the following is true about the parent function p of x equals the absolute value of x? I put in a suggestion, think of the graph. So first thing that comes to mind is, what is the graph of absolute value of x? It's a V, centered at the origin, okay? So it's a V sitting here, where the vertex is right there. All right, so P has a maximum. No. If anything, P has a minimum here, because this is a minimum, not a maximum at 0. P is decreasing for x less than 0, which is on this side. So look at the graph. You see the graph is going down on this side. It's always from left to right. So as we move in this direction, this graph is headed downwards. So, and that means it's decreasing. So the correct choice is B. It's decreasing. But let's check everything else out. P is changing faster at x equals -7. Which is way over here, and x equals -1, which is here. And the answer is no, it's not. It's actually decreasing at the same rate because these are lines. This is a line right here, which means it has a constant negative slope. And then P has a domain that's restricted to positive values. Domain is X. And as you can see from this graph, it can be both positive and negative. So the only correct choice is B. All right. Now on 14, X equals the opposite of X minus 3, X plus 2. And here's the sketch. It is shown, give the coordinates of point A, point to the left. Okay, so this right here, so you should mark it on your paper. That is point A. Then this must be point B. All right, so give coordinates of point A. Well, what they're asking you to do is solve this quadratic for when it's equal to 0. So you get 3 comma negative 2. So negative 2 is to the left, so A, this must be negative 2 and this must be 3. So give the coordinates of point A, point to the left. Point A is actually going to be negative 2 comma 0. Give the coordinates of point B. It's on the x-axis. It's to the right, so this would be 3 comma 0. And then find the axis of symmetry. Well, you take your two x-intercepts and find the midpoint by finding the average. So the AOS is going to equal negative 2 plus 3 over 2, which is 1/2. So that's the axis of symmetry. X equals 1/2, which would probably put you right about there. Okay? So there you go. The next question is the graph of a quadratic function has x-intercepts. They tell you the x-intercepts are negative 4 and 8. They want you to find the x-coordinate of the vertex of the parabola, the AOS. Well, that's the same question as up here in part C. Find the axis of symmetry. Except for this one's a little bit easier because they give you the x-intercepts, so you don't have to deduce it. So the axis of symmetry is going to equal negative 4 plus 8 divided by 2. Which is 4 divided by 2, which is 2. So the axis of symmetry, it's the axis of symmetry, but it's also the x-coordinate of the vertex. X equals 2. Okay? So now this is a thinking question. If f of a equals f of 9, find the value of a. This is all about the fact that the axis of symmetry that the distances from the axis of symmetry to the two values are equals. What does that mean? If this is, let's say this is 0, 1, 2. So here's 2. That's the axis of symmetry. So you can think the axis is sitting here. Now, they said f of a must equal f of 9. F of 9 is way over here. And there is 7 units to the right. Well, due to 7, how did I get 7? It was 9 minus 2. So that's 7. Well, there must be the other value symmetric across the axis of symmetry, which means it must be 7 units to the left. Which means we take 2, so A would be 2 minus the distance of 7, which is negative 5. So A must equal negative 5. Again, it's not hard, but you do have to think about it. It's talking about the symmetry. All right, question 16. Consider the function given by g of x equals x plus 1 squared minus 4. Identify the vertex of the parabola. This is the vertex form. The vertex form is g of x equals x plus h. No, excuse me, x minus h, because your x's are liars, squared, plus k. And the vertex is at h comma k. So when you look at this number here, this plus 1, indicates what the x value is. Just remember your x's are liars. So instead of saying positive 1, you're going to say negative 1. And then it'll be negative 4 for the y value. Identify the axis of symmetry. Well, that's just going to be x equal to, well, or, negative 1. That's the x value of the vertex. Now graph. So here's the axis of symmetry. It goes down this, right? Boom, 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 boom. The vertex is at negative 1, negative 4. So here's the vertex. And then you either choose values of x, like when x is 0, plug it in. You get 1 squared minus 4 is negative 3, which puts you here. And then you could say when x is 1, that's 1 plus 1 is 2 squared minus 4. And that's 0. So when x is 1, you're at 0. When x is 2, 2 plus 1 is 3. 3 squared is minus 4. That's 9 minus 4. And that's 5. So you could sit here and, okay, so when x is, so this is x equals 1, x equals 2, x equals 3. So x equals 2 is at 5, and I think that's as high as you can go. Because if you go to the next one, and you plug x equals 3, 3 plus 1 is 4, 4 squared is 16, minus 4 is 12, and it's well off the grid. And then we just remember symmetric, so we put the other points on the same distance away at the same level. So this is 1, 2, 1, 2. This is 1, 2, 3, so we got 1, 2, 3. And there's your graph. All right, and that's how you graph it. Now, what I've been saying, and what I did was I just went over and chose x values and plugged them in and evaluated this expression in my head, so to speak. So when x was 1, 1 plus 1 is 2, and you got 2 squared minus 4, which is 0. So when we're at 1, we're at 0. And then I said when x is 2, 2 plus 1 is 3. 3 squared is 9, and that gave us, so we had this. 9 minus 4 is 5. So when x is 2, we're at 5. I could also have done it my old way, which is starting at the vertex, we go over 1, square 1, and we go up 1. And that puts us at the same point. We go over 1, 2. 2 squared is 4. We go up 1, 2, 3, 4. Same point as when I plug the x values in. And if I went over 1, 2, 3, 3 squared is 9. And we go up 1, 2, 3, 4, 5, 6, 7, 8, 9. So you see it fits that pattern. And it always fits that pattern. That's why I don't really plug x values in. I just follow the pattern. Over 1, up 1, over 2, up 4, over 3, up 9. Okay? All right, for number 17, it says solve each equation with the quadratic formula. Give exact answers. So they tell you to use the quadratic formula. The quadratic formula is x equals h plus or minus the square root of h squared minus c over a, where h is the opposite of b over 2a. I will give you this formula to use on the test on a formula sheet. So obviously you need to know what a, b, and c are because they are involved in this equation. Again, a is the number in front of the square term. So this a would be here, b would be there, and this would be c. Make sure that you have 0 on this side. If you do not, you're going to have to rearrange it so you can have it equal to 0. But it's already equal to 0, so you don't have to rearrange. B would be -3, and C is -14. So the first thing I would do is evaluate what H is. H equals the opposite of B, so B is -14, so that's a +14, all over 2, I'm sorry, I said 14, didn't I? B is -3, so the opposite is +3. over 2 times 1. So h is 3/2. I would leave it as a fraction because it's okay. And then d, which is the square root of h squared minus c over a, is then the square root of 3/2 squared minus c, and c was negative 14, so minus a negative 14 over a is 1. Okay? So this equals the square root of 9/4 plus, because minus a negative, pay attention, minus the negative is plus 14. All right? So 9/4 is 2 1/4, right? Because 4 goes into 9 2 times the remainder 1. So 9/4 is 2.25 plus 14. So it equals the square root of 16.25. So x would equal 3/2 plus or minus the square root of 16.25. Now, you would have used a calculator to evaluate all this. In other words, I would have typed in 9/4, 9 divided by 4, plus 14, gotten 16.25, and just left it as this. So this is the exact answer. Now, some students, some of the kids who are on top of things and like to overachieve would realize 16 2/5 is the same thing as 16 1/4. And then 16 1/4 you can write as an improper fraction by multiplying 16 by 4. So 10 times 4 is 40. 6 times 4 is 24. 64, and then add the 1, and this becomes 3/2 plus or minus the square root of 65 over 4, which is 3/2 plus or minus the square root of 65 over 2. And you could have written it like this. Matter of fact, if you use the old school quadratic formula, which you're more than welcome to use, you would have gotten this answer. Using the other form, you would have gotten this. They are both correct. Just use one or the other, okay? Now, you only have one where you have to use the quadratic formula. Now, on the next one, it says write in intercept form. So that means we want to write this in factored form. So factor this polynomial. So whenever you factor, first thing you look for is the greatest common factor. You want to GCF if you can. To do this, we see that we got 5x squared and a 50x. They both have 5 common to each other and x. Okay? Because 5 goes into 50 and x goes into x squared and x. So what we're going to do is pull a 5x out and then backfill the parentheses. What do you have to multiply 5x by to give us 5x squared? That will be x. What do you have to multiply 5x by to give us 50x? That would be 10. And this is the intercept form. Okay? Because from this, you can see that one of the intercepts is x equals 0, and the other one is x equals negative 10. All right, that's 18. All right, moving on. Solve each equation by factoring. So this is all about the old F word of factoring. We look for product sums. GCF it if we can. So on this one, we can't because there's nothing common besides 1. Then we look for product sums. So I'm looking for two numbers that multiply to 21. This multiplies to this back number and adds up to the middle number of 10. So you have to think about what times what gives you 21. There's only 21 and 1. That won't work. And then there's 3 and 7. And that will work. Okay? So we can double check it. 3 times 7 is 21. 3 plus 7 is 10. It works. So we can rewrite this quadratic into intercept form or factored form. Notice this is equal to 0, which means either p plus 3 is 0 or p plus 7 is equal to 0. So one solution is p equals -3. The other solution is p equals -7. And that's your answer. You just solved it by factoring. All right, it's not that hard. Doing 21, a little bit different. Notice we don't have that third term. But remember, I always tell you, when you factor, always start by trying to GCF. So can you GCF? Is there anything common between the first term of r squared and the second term of 8r? And you will say yes, at least I hope you will. It's r. So what that means is we'll have r on the outside, and then we're going to have to backfill the parentheses, and we get this. All right? All I did was, once I had this r out here, I said, okay, r times what will give me r squared, and that's going to be r. R times what will give me -8r, and that's -8. And this gives us two solutions. This gives us r equals 0 and r equals 8. The solutions. Okay? That was 21. We're moving along. Now, 22 and 23 are just what we were studying just the other day. We just got this in. So they want you to sketch the graph of each function, state the domain and the range. To graph these, the easiest thing to do first is look for the horizontal asymptote, which you just look. Is there a number being added or subtracted at the back end? For 22, there isn't. It's just 0. So the horizontal asymptote's y equals 0. So that tells me I can put a horizontal line along y equals 0, which is the x-axis. That's going to be my guide. All right? And then you can make a table and write them down, or you can do this in your head. So I'm going to look at, and when x equals 0, you get 3 to the zeros. 3 to the 0 is 1. So that puts us right there. When x is 1, we get 3 to the first. 3 to the first is 3. So that's 1, 2, 3, and that puts us here. When x is 2, we get 3 squared, which is 9. So when x is 2, we go all the way up. All I'm doing is evaluating 3 times x, all the way up to 9. When x is 3, that's 3 to the third, and that's 27, which is off the grid. 27 is way up here somewhere. So, and then when we go negative, it's 3 to the -1 is 1/3. You don't really, there's no way of really getting an exact value placement of that because they're decimals. So just know that it's going to bend and follow this graph, the horizontal asymptote. That's why we lay it down, and just make sure your graph goes straight up like that. And there you go. State the domain. Well, this is an exponential. Domain is all reals. And the range is going to be all reals. Y is greater than 0. Because it's above the x-axis. Notice I didn't say greater than or equal to. It's just greater than, because it never actually gets to the horizontal asymptote. All right, and that's pretty much it. Now look at 23. Y equals 2 to the x minus 1. First thing you should do is lay down the horizontal asymptote. The horizontal asymptote is y equals -1. So that's a horizontal line down here. And then you could just evaluate this. So I'll start at 0. When x equals 0, you have 2 to the 0 minus 1, which is 0 because 2 to the 0 is 1. And 1 minus 1 is 0. So when x is 0, we're right there. When x is 1, that's 2 to the first minus 1, and that's 1. So when x is 1, we're at 1 for y. When x is 2, that's 2 squared minus 1, and that's 3, because 2 squared is 4. So 2, we're at 1, 2, 3. When x is 3, that's 2 to the third minus 1, and that's 8 minus 1, which equals 7. And when x is 4, that's 2 to the fourth minus 1, which is 16 minus 1, which is 15. And that's the last one, 1, 2, 3, 4. That's the last dot that will fit. Now I'm going to redo these dots in yellow because I wanted this graph to be in yellow. All right, and then the rest of these, just know that as we move to it just approaches the horizontal asymptote. And there's your graph. The domain, just like on the previous one, is all reals. The range is all reals, except y is greater than the horizontal asymptote, which is -1. And there you go. Again, making the graphs is not too bad because these are not ugly numbers we're dealing with. Now write the exponential function. Okay? We have 2. Notice on 24, the first thing you should notice, it's growth. That means the graph is blowing up to the right. That means b is greater than 1. Not only that, you know that the y-intercept is 0, 1. So when we're talking about y equals a times b to the x plus k, we know the horizontal asymptote is y equals 0, so we know k equals 0, so we don't even worry about it. And we know the y-intercept is going to be when x equals 0, so that's going to be a times b to the 0, which is 1. So a equals 1, because this equals 1. That's already 1. So a is 1, and you have the equation, y equals. Now, to get b, I didn't mention this. To get b, you look at when x is 1, because that gives you b to the first. So we get here b to the first is equal to 3. And that tells you what b is. So this is y equals 3 to the x. You could check it real quick. Plug x equals 2. This graph says that you should be at 9, and 3 squared equals 9. It works. So that's the equation. Now the next one's just like the first one, except now the whole graph is shifted down. The horizontal asymptote is y equals -1. Okay, notice at x equals 0, the graph goes up 1. That means that a equals 1 in the y equals a times b to the x. So I'm going to basically treat y equals -2 as the x-axis now. So when we're at 0, we're at 1. When we're at 1, we go up 1, 2, 3. So that tells you b equals 3. So now we have y equals 3 to the x minus 2. Again, you basically treat the horizontal asymptote, which is this is the HA, as the x-axis for this graph. So instead of looking here, when at x equals 0, we went up 1, right? Here at x equals 0, from the horizontal asymptote, we went up 1. That told us A was 1, okay? Because the y-intercept is basically 0, 1. All right? And okay, so and also when x is 1, we go up 1, 2, 3, so the base is 3. And there you go. That's how you do this. It's not hard. You're going to spend next week really looking at this. And yeah, that's it. Have a wonderful day. Bye-bye.